Today, class, we're going to talk about the concept of arrays. Arrays are a data structure that you can use to store multiple values of the same type under one variable. Up to now, if we want to store a value, we have to declare a variable and we have to store the value we want in that variable. So for example, if I want to store the value of 5 in a variable called x that's an integer, I can declare it and set the variable to the value 5 right there. But for example, let's say we want to store a bunch of names and they're strings. So here I've got 6 different string variables defined to store 6 names. As my program runs, it's going to become very cumbersome to try and figure out which name I want to work with at a given time. An alternative solution would be to use an array. So an array is a non-primitive data type that stores multiple values under one variable name, and they all have to be a single type. So you have to store all integers in a single array, or all doubles in a single array, or all strings in a single array. You can have different arrays with different types, but the data in a given array has to be of all the same type. So as an example, we could think of a container of tennis balls as an array. The top ball in the container is at the 0 position. Now we can think of this as the first position, but in a second I'm going to explain to you why the beginning position is position 0. The middle ball is at the first position, and the bottom ball is at the second position. This container is an array of tennis balls. The data type in this array is tennis balls. I can't store a ping pong ball in this container of tennis balls because it's a different thing. When I'm talking about a particular item in the array, I reference it as the variable name and then a square bracket and then its index. So the number indicates the location in the array where that particular item is. So if I'm saying t-ball, open bracket, 1, close bracket, I'm saying t-ball at location 1. Now, all the items have different locations. In this case, we have locations 0, 1, and 2. These location references are called the indexes or indices. Now, in Java, all locations start at position 0. So the beginning location in an array is position 0. So if you have 3 items in the array, the last position in that array is going to be 1 less. It's going to be 2. In Java, we say that arrays are 0 indexed, which means that they begin from position 0. Now, let's go back to our names problem we were talking about. Instead of having 6 different string variables for the names, we could have one string array with 6 locations. And I can define it as, I just give the variable name, and I say string names, and I put open and square brackets. I'm defining an array is going to be a new string array of 6 locations. So I can store up to 6 names in this array. Then I could assign each location in the array to a particular name, and I could do it this way. I could say names at position 0 is Yun, names at position 1 is Ann, etc. I cannot do a names at position 6 because there is no position 6 in the array. The beginning position is position 0, the 6th position is position 5. Now, if you wanted to, you don't have to declare your arrays this way. You could declare it this way. You could declare the array called names and open and square brackets, and then you literally populate the array with the values you want to give it. So I didn't have to say there were 6 locations. I just defined it with 6 items. Now from this point forward, I cannot add any more items to this array. I can change the values in the different locations, but I cannot add on another item. So if I wanted to find out what the value in an array at a particular location is, I use its index. So if I want to find out what the variable names at position 3 contains, I could say some string is names at 3. And when I ran that program, I would get 0, 1, 2, 3. Ahmed would be the value of the array called names at position 3. Now, the question is there a names at position 6? There is not, because our indexes start at position 0. So if you start at 0 and count 6 places, you get 0, 1, 2, 3, 4, 5. Position 5 is the last position in the array. If I tried to reference location 6, I would get an array index out of bounds exception because there is no position 6 in that array. So I'm going to show you a little example of a program here. So here was the example in the presentation. I've declared my array called names, and I've initialized it with the 6 names. So if I run this right now, it says that names at 3 is Ahmed. If I change that again and I say at position 1, it tells me that Ann is at position 1, 0, 1. If I try position 8, there is no position 8 in this array. It only goes up to position 5. So I get an array index out of bounds exception. Okay. Now we'll just quickly look at the arrays lesson that's in the House of Pain in the unit. So this is just more detail about what I've been describing. It talks about that when you create an array, arrays of type int or double or char, even if you don't specify the initial values, all those values start at 0. Strings start at null. Null means nothing. It's an empty string. I'm going to leave all of these for you to read on your own to understand what's going on. Here's an example of printing out all the items in an array. So here I have my index counter starting from 0 to less than names.length. So if names has 5 positions, it's going to count 0, 1, 2, 3, 4. And then it'll just print out the name at that index. As I said before, you can initialize an array to values if you want. Now in section 7.4 of the textbook, we talk about parallel arrays. Parallel arrays are just arrays that have different kinds of information, but they're the same number of items in all the arrays. So if I have a name array and a marks array, here I have an array of 3 locations and a mark array of 3 locations. So this is a name array and marks. So there are 3 names and 3 marks. The 0th position mark of 85 goes with the 0th position name David. The first position with a mark of 100 goes with the first name position of Sue, and the second mark position of 88 goes with the second name position of Michelle. So I can relate different information together by using parallel arrays. So for the next few days, you're going to work through some practice problems in the chapter. Please take your time. This is not a rush. We'll start talking more about things next week as far as assignments go. Don't worry about it. Let's just go nice and slow, take our time. I'm going to just go back to this presentation for a second because I just want to talk briefly about an extension of arrays. Arrays can have more than one dimension. When we define an array with only one parameter, so like this, names 6, that means that this is a single dimension array with 6 locations in the array. I can do a 2-dimensional array. And a 2-dimensional array can be a representation of rows and columns. So if we think of a dozen eggs, if you think of the carton that the eggs come in, you have 2 rows and you have 6 columns in an array in a carton of eggs. So the rows can be referenced by rows 0 and 1, and the columns can be referenced by the rows 0 to 5. So if we want to find out if this is an array of the masses of the eggs in the carton, so each of these white numbers is the mass of each egg. If I wanted to find out what the mass of the egg in the first row, third column, I would go to the first row, third column, and that would tell me that the mass of that egg is 15 grams. Now we've all used two-dimensional arrays in our lives at this point. If you've ever played the game Battleship, that's a two-dimensional array. It has rows that are denoted by numbers, and it's got columns denoted by letters. So if I want to fire a shot, try and hit a boat, I could say F6, and you would look on your board, and if your boat had part of the boat covering F6, you'd say hit, and I would then put a little red marker in my board saying that I had hit your boat there. So we're using rows and columns to refer to different parts of this array. You can think of the ocean as an array, and the boats are located at different parts in the ocean. Playing tic-tac-toe is a two-dimensional array. You've got rows and columns. And so if I played the X here, I would play at row 1, column 1. This 0, this O, is at row 0, column 2. And then if you've used spreadsheets, these are classic two-dimensional arrays. You've got individual columns that are different types of data. And you've got the rows. We would call this a record. So here we'd say the customer is called Red. They're in the West region. Their product is dark chocolate. They have 211 of those on hand, and they've sold a total of $443.10 worth of red dark chocolate. Or the red customer has sold $443 of dark chocolate. This is also an example of parallel arrays. So these could be individual arrays. We could have a customer one-dimensional array that would have 12 customers. We'd have a regional array of 12 regions. We'd have a product one-dimensional array of the products. We'd have a quantity one-dimensional array of 12 quantities for those customers. And then we'd have a sales array of 12 locations, 12 values. So that's the overview of arrays. I'd like you to start working through, you can look at the other lesson that's in the House of Pain section on arrays. This one here that I've gone through briefly. I want you to read the chapter so you can get more in-depth information about the arrays, how to use them, and then you can start working through those problems. Again, don't rush yourself, take your time. If you have questions, please either post them to the stream on the Google Classroom or direct your questions to me directly. Thank you very much and have a great week. Bye.